Okay, hello. We are going to talk about in this video multiplying, dividing rational expressions. This is part one of two videos, and for your title, you are going to say, this is for unit 3.12a, and we are multiplying rational expressions. Okay, multiplying rational expressions. All right, so the vocabulary that's going to be highlighted in this video are conjecture, product, factor, simplify, denominator, factors, and numerator. A conjecture is probably the only new term that has come that is new. Conjecture is a statement believed to be true based on observations. All that really means is we are going to probably make some assumptions when we're doing when we are multiplying some rational expressions. Okay. Now, let's take this example, 2/3 times 4/5. We know how to do this. I'm just going to show the steps so that way we can see that connection with rational expressions. So we have 2 times 4 over 3 times 5, right? So we multiply the numerator straight across and the denominator straight across. So then we'll get 8 over 15. Now this application, the way we simplify this or find the product of this is very similar to rational expressions, which can be explained in this rule if you want to take a look at that. Okay, so make sure you write this rule on the sides. It's important key point here. So then right here, we're going to elaborate more on what happens when we have a rational expression and how do we simplify that when we are multiplying them. Okay, so right here it says make a conjecture about the product x cubed over 4 times 16 over x. What will it be? Explain your conjecture and give evidence that it is correct. So make a conjecture is a key word, and about the product. So I need to make a conjecture about the answer that I get from this rational expression. Okay, so here I'm going to rewrite the problem, and so that's x to the third power over 4 times 16 over x. I'm going to go ahead and rewrite that. So 16 or x cubed times 16 is the same as 16 x cubed, and then we get 4x. Okay. Now we need to reduce this or simplify it. And I'm going to be strategic about this, and I'm going to separate 16x cubed to a possible term where I can reduce it using the property of 1 with this 4x. Okay, so how I'm going to do that is I'm going to write 4x times 4x squared, because when I multiply these two together, I still get back to 16x cubed. Now, I'm being strategic because I want to eventually reduce this to the property of 1 with my denominator. Now, here this is the same thing as 4x times 1. Okay, so now that I have 4x over 4x, I can apply the property of 1, and I have 1 there, and my final answer is going to be 4x squared over 1 or just 4x squared. Both answers are valid. Now, making a conjecture, what does that mean? So I'm going to go ahead and type out my conjecture just for the sake of time. So right here, I can say, I'm going to make this 10. So I can say, I believe that the original rational expression will, or I believe that the original, I believe that the product of the original rational expression will be 4x squared, because when I multiply the numerator and denominator, and then simplify, And then simplify, sorry. Okay. I believe that the product of the original rational expression will be 4x squared because when I multiply the numerator and denominator and then simplify, I will get the reduced rational expression similar to rational numbers. Alrighty, so number 2. So it says here, make a conjecture. So I have to explain again. Make a conjecture about the product of x cubed over 4y times y squared over x. What will it be? Explain your conjecture and give evidence, right? So I forgot to say this, but right here it tells you to explain. So that means we have to use some math vocabulary, right? So right here I said multiply, I said numerator simplify, reduce, okay, product. All of those things are really strong explanation statements. So here, explain your conjecture and give evidence, right? So math evidence. All right, so let's do this. So we have x cubed over 4y times y squared over x, right? So I'm going to multiply straight across just like I would do with rational numbers. So I get x cubed times y squared, and then I have 4y times x, okay? There's a way to reduce this by using your exponent rules, but I'm going to cover that later on. Instead, since my powers are smaller, I'm going to just expand these. So I get x times x times x times y times y. Okay, and then here I'll have 4 times x times y. Apply the commutative property to switch my factors around just so I can be more strategic about applying the property of 1. So right here I can see x over x will give me 1, and then y over y can give me 1 as well. So then this will equal x squared y and over 4. Okay, and so I'm going to explain my conjecture. So right here I'm going to say I believe that the product of the original rational expression will be x squared times y over 4 because when I multiply the numerator and denominator and then simplify, I will get a reduced rational expression similar to rational numbers. Okay, great. Moving on. Example 2, this one is somewhat unique. Many of you may think to distribute this 1/3 to this binomial and then multiply it by 9. However, there's another way that we can do this, again, a little bit more strategically. Okay, so it says to multiply. So here I'm going to have, this is similar to 1/3 times x minus 2. And it's also being multiplied by 9, so times 9. And then from here, I'm going to apply commutative property and switch these factors around to help me to multiply these a little bit more strategically, because 1/3 times times 9 gives us 9/3 or 9 over 3, which then reduces to 3x minus 2, right? Now, I can go a step further and say this becomes 3x minus 6. And that's it. Okay. Next one, we have some key points. So your key points here for these more complicated rational expressions are, first, you always want to factor out a GCF. Factor out a GCF. Okay. Sometimes you may have to factor out special factors, such as difference of squares, difference of sum of cubes, or difference of cubes. So just know that sometimes instead of a GCF, you want to check to see, do I have maybe a difference of squares, for example? Or do I have a sum or difference of cubes, right? So not letting go of those key things. And then step 2, we want to eventually, we want to factor out GCF, then we want to multiply across. And then step 3 is to simplify. All right, so step 1, let's check out if we have a GCF, right? But first of all, if you're like me, I'm always like, attack the math. But really, I probably should read directions. So find the following product. Okay, cool. So I have to find the product, which means, cool, I could do my factoring. So here, check my numerator, x minus 2. Nope, I don't have a GCF, nor do I have a special factor. 3x plus 9. Yep, I do. I can factor out a 3. I get x plus 3. Rewriting. Okay, and here, 3x plus 6. I do have a greatest common factor, which is 3. And I factor that out, and I get 3 times x plus 2. Then down below, this denominator, my GCF is 2. So I can factor out a 2, and I am left over with 2 times x minus 2. Cool. Now what I can do is I'm going to rewrite all of these because they're essentially being multiplied. All of these are being multiplied. So I'm going to multiply, not yet, because remember my goal is to simplify. So do not expand these. Don't do x minus 2 times 3 times x plus 2. We want to see what can we reduce first before we do that. So we have x minus 2 times 3 times x plus 2. I'm just showing that I'm writing everything on top of the numerator and I'm multiplying them. And then I have 3 times x plus 3 times 2 times x minus 2. Okay, now I'm going to clean this up further by applying the commutative property. So I'm going to do 3 times x minus 2 times x plus 2. And then my denominator, I have, let's do 3 times 2 times x minus 2 times x plus 3. All right, so what I can do now is I can apply the property of 1. So I have 3 over 3, that gives me 1. X over x minus 2 over x minus 2 gives me 1. So I'm left over with x plus 2 on the numerator and 2 times x plus 3 in my denominator. And that's fully reduced. Right, last example. Here we go. Okay, same thing. Find GCF. Okay, GCF for my numerator is 3, so I have 3 times x minus 2. And then here, my GCF is 2. Factor out of 2, I get x plus 3 times. My GCF is 5, so I have x plus 3. My GCF here is 4. I have x plus 2. Cool. Now I'm going to write them all on top, and I'm going to apply commutative property as well. So I have 3 times 5 times x minus 2 times x plus 3. And then from there, apply commutative property one more time. 2 times 4 times x plus 2 times x plus 3. Okay, and then from there, I simplify or reduce by seeing which factors I can apply the property of 1 to. So I have right here, x plus 3, this binomial becomes 1. Do I have any more? Nope. So then my final reduced rational expression is going to be 3 times 5 is 15, x minus 2. 2 times 4 is 8 times x plus 2. And that's my reduced rational expression. All right, so summarize what you've learned. Write incomplete sentences. Optional word bank is given here. So summarize this and watch your next video. Bye.